All right, this example of determining whether a salt is acidic, basic, or neutral is a little bit more challenging. But again, I'm going to start by writing down the equation for the dissociation of my salt. Okay, so one thing that we'll see pretty common in these examples is salts containing cations with nitrogen and hydrogens. These are amines, and so this is similar to the ammonia compound. And so as a cation, it can potentially be acidic. So I need to consider its conjugate base. So its conjugate base is going to be the same compound, just -1H plus, and so I have the conjugate base is C2H5NH2. This is not one of the 8 strong bases, so we can assume that it is a weak base. So if this is a weak base, then that means that its conjugate acid, the cation that we have in this problem, is also weak. In this case, it's going to be a weak acid. All right, so now I need to do the same thing and consider my anion. And so it's either going to be basic or neutral. So I consider its conjugate acid. Its conjugate acid is HClO2. This is a weak acid. So that means that its conjugate base, Cl2 minus, is a weak base. All right, so the reason this problem is a little bit more challenging is because I have both a weak acid in my salt and a weak base in my salt. And so to determine whether the salt overall is acidic, basic, or neutral, I need to compare the Ka for the cation, and I need the Kb for the anion. Whichever one is bigger dominates, and so if the Ka of my cation is bigger, then it's going to be acidic. If the Kb of the anion is bigger, then it's going to be basic. So let me go to a new slide. All right, so typically the Kas and Kbs that we need aren't going to be listed in our textbook. Instead, the things that are listed are the Kb of C2H5NH2 is 5.6 times 10 to the minus 4. And we know that the Ka of HClO2 is 1.1 times 10 to the minus 2. So these aren't the actual quantities that we need. We need the Ka of C2H5NH3+, and we need the Kb of Cl2 minus. But we can use the fact that the Kas and Kbs of conjugate acid-base pairs are related. So that means that the Ka of our cation is equal to Kw over the Kb of C2H5NH2. So that means 1.0 times 10 to the minus 14 over 5.6 times 10 to the minus 4 is 1.8 times 10 to the minus 11. And just a note, I forgot the positive charge there on my cation. All right, now I'll do the same thing for Cl2 minus. So that means the Kb of Cl2 minus is equal to Kw over the Ka of HClO2. So that's 1.0 times 10 to the minus 14 divided by 1.1 times 10 to the minus 2. And when I do that, I get the Kb of Cl2 minus is 9.1 times 10 to the minus 13. So in this case, the Ka of my cation is bigger than the Kb of my anion. So this is bigger. That means my salt overall is going to be acidic.